And welcome to Chapter 14, where we'll be studying the behavior of gases. In this chapter, we're going to have 4 different objectives, which we'll be listing in just a moment. We'll be talking about the kinetic molecular theory, the idea of pressure, gas laws, and then also how gases behave in mixtures. Okay, so let's go ahead and list those objectives. Again, we're going to review the kinetic, molecular theory. Sometimes it's just abbreviated KMT. That's actually from Chapter 13. We're going to take a look at, in particular, pressure. It's one of the parameters of a gas that you may be less familiar with. We're going to take a look at the gas laws, including the ideal gas law, and all the calculations that are associated with that. And then finally we'll be looking at mixtures of gases. Okay. Now as we go through this chapter, we're going to be working with 4 different parameters that to describe a gas. We need to know the amount of gas that we have, and that will be listed in moles. It's also given the abbreviation N. We need to know the volume of a gas. Typically, we're going to be measuring things in liters or changing them over to liters. We give that abbreviation V for volume. We need to know the absolute temperature. And that will be measured in kelvins, K. When we're using temperature in the gas laws, we'll be using a capital T to denote that temperature. And finally, we need to understand pressure. Pressure will be measured either in what are called atmospheres or kilopascals. We're actually going to introduce you to a few other units as well, but those are the 2 primary ones. And when we list pressure in a calculation, we use the letter P. Alright, so those are the 4 parameters that you need to describe a gas. Alright, so let's go ahead and jump in. First objective is to review the kinetic molecular theory. Now, the kinetic molecular theory is what describes how particles behave, particularly in the gas phase. So, for example, the first tenet of the kinetic molecular theory will simply say that gases or gas particles are hard spheres that occupy a negligible volume. Simply meaning this: we treat them like tiny spheres, but when we calculate the volume, we ignore that they're in there. All right, now that's not entirely true, but that is one of the assumptions that we go on with this theory. Next, we assume that gases or gas particles do not exert a force on each other. Simply meaning they do not repel each other, they do not attract one another, they do not influence one another. They can collide, but they're not going to be slowing each other down or speeding each other up with any type of force. We also assume that the motion of particles is random, rapid, and constant. Rapid, random, and constant. These particles are flying around. And finally, we assume that all collisions are elastic. simply meaning they don't slow each other down when they collide. They have the same momentum when they leave as they had when they before they collided. So let's just draw a little picture here. Maybe it'll illustrate what these 4 points are all about. First of all, if this is our box, our container that the gases are in, we assume that they're tiny spheres, like so. And we'll try to fill this box somewhat uniformly, but randomly. All right. So you have these tiny spheres, but you ignore their volume. So when you take the volume of this box, we assume that you have the entire box available. You do not count, or you don't worry about the fact that these particles take up some space. They also do not exert a force on one another. So if this particle is moving in this direction, this gas particle and this gas particle are not going to steer it one way or the other because they're attracted to it, nor are they going to slow it down as it approaches the container wall. So that's one of the assumptions that we're going on, is that they do not influence one another. Also, these particles are moving in a constant and rapid random fashion. So there's no way necessarily to predict the direction that any one of these particles are moving. They are always moving, and they're moving very, very quickly. Something on the order of 1,000 miles per hour. All right. And when they do collide with one another, they bounce off each other without any impact on one another. They simply change each other's directions. All right. So those are the tenets of the kinetic molecular theory, and we're going to be using those as we progress and move through our understanding of these gases. Okay. In the next podcast, we're going to take a look at what pressure is and what influences the pressures that these gases exert. Okay. We'll see you next time.